I'm going to get started. We've lost some people, but it's late in the day, so understand. Thanks for staying out this long, going through all these great talks. Once again, I'm Joe McManus. I'm a scholar in residence here. I run the network security program here in ITP. And as I said before, I'm a senior researcher at CERT, part of the Software Engineering Institute at Carnegie Mellon. Our talk today is going to be the future R&D goals in InfoSec. So I'm going to hand this down and introduce themselves.
Hi, my name is Jacob Torrey. I'm an advising research engineer at Assured Information Security down in the Tech Center. We do kind of boutique cybersecurity research, mostly for the federal government, but also now for some commercial entities as well.
Hi, my name is Alex Kryline. I'm a PhD candidate at CU Boulder. I'm also the managing partner of SecureSet LLC. We are one of the world's first cybersecurity startup accelerators. My background has been at Department of Homeland Security, as well as NIST, and doing work in the IT and InfoSec space for a while now.
Hi, I'm David Odom, and I've got this really cool stealth mode platform here, but that's really just a early stage venture fund that I'm launching or in the process of. I think I'm here at the table because prior to that I was with Arsenal Venture Partners. Arsenal is a strategic venture fund manager that focuses on investments in the intersection of really government agencies, particularly the Department of Defense, and commercial markets, runs the U.S. Army's only Department of Defense venture fund, corollary to InfoSec. And in a past life, I was a developer and product manager for a number of global telecom deployments.
And I'm Vern Mosley. I'm a senior cybersecurity engineer within the FCC's Public Safety and Homeland Security Bureau. And my job there is I help ensure that the communications companies are resilient to cyber incidents. And so my background has been in the engineering and deployment of both physical and cyber networks that supported national security and emergency preparedness missions.
Okay, so for our first topic today, we're going to talk about what the biggest security concern for the future of telecom networks is. From my perspective, I think one of the things we have to face is just the bandwidth increase. Just a few years ago, you were cutting edge if you were monitoring 10 gig. So now it's 160 gig. Yeah. Now it's now you're monitoring it at the MPLS level. You're monitoring at these huge data sets. So how do we provide security while monitoring in real time or near real time? I'm a big fan of flow, and I'm a proponent of that, but at a certain point when you have that much data, you have to spend a lot of time creating analytics that are actually useful. Additionally, for what's going to go into our second question, we had a very great pre-conference call where we decided to talk a little bit more about the Internet of Things with this. So now when everything is connected, how do we monitor this huge, large scale of devices on our networks? So with that, I'll hand it down.
Yeah, to talk on that, Alex Stamos, who is now the CISO at Facebook, had a great keynote. Basically, that AppSec is eating security. Essentially, the fact that as we get faster and faster and faster, I mean, the time it takes a 10 gigabit, 40 gigabit firewall to be able to make a decision about a packet is less time than it takes a photon to bounce off your foot and into your eye. So you have such a tiny amount of time and the power constraints for that. So we really need to start focusing on protecting the endpoint, not through monitoring, but actually building in security, as well as this AppSec problem. It is a huge security skill shortage, and it's kind of one of these niche areas that I know everyone that I'm talking to is looking for people. Back to the original question, I think we're seeing a lot more siloing. Every Internet of Things device has the new standard, and every standards organization has their own standard for how these devices are going to communicate. And you have a lot of different kind of cross-layer impacts that aren't truly being measured. So the Rowhammer attack is a great example of a physical attack that's happening down at the very, very low level of integrated circuit development that has a very high level and high risk impact at a web application, for example. And so as we start breaking down into these more and more divided silos, you're going to run into the risk where you'll be able to cause some unknown and unintended consequences in a completely different layer of your product.
So I think there's a couple of interesting considerations from like an analysis perspective. There's one thing to be able to collect an enormous amount of information, right? And I think that's what a lot of security analytics firms are attempting to do. And so you have this collection of all this data, but it almost immediately goes static, right? So like if I have like a large selection of IPs that I can identify as being threat actors, those IPs go dead within like a day or two. So like, can I make decisions fast enough to be able to be actually effective? I'm interested in a couple of other areas. I know that everybody clamors about IoT, and I think there's real considerations to have. I'm not particularly convinced of the security threats there specifically being vastly different from a lot of other internet connections. But there are some unique considerations like access control and identity management, right? That's a really interesting area, I think, of future research that needs a lot of consideration because, I can try and find a zero-day exploit in software on some, firmware of a device, and that's an important thing to be able to do, but it's also just a lot easier if I can take your credential, right? So, if I just send you a phishing email and you're an idiot and you click on the link, which everybody does, that was so much more of an efficient use of my time than trying to, reverse engineer bytecode. That's hard to do. Phishing's a lot easier to do, and it's from a time value perspective a lot more effective. But what that kind of gets into is I think a really important area of research for telecom networks, which is understanding that the traditional risk calculus that telecom networks have gone into the field with is not applicable. So it is not the same to consider risk calculus similarly to that of a nuclear regulatory industry as opposed to what it is to do it for an advanced and adaptive and agile threat actor. And so the foundational business logic by which people approach information risk analysis is not analogous to the actual outcomes that firms have to make. And so when they go into this thinking that, I can just, there are threats and I'll just quantify and rank order them and from 0 to 9 or something like that, that's not actually effective and it's not predictive. So a big focus for telecoms as they start turning up new services like network function virtualization or software-defined networking, which more closely abstract out different layers of the stack, make it much more vulnerable, and so they'll have to integrate more threat intelligence thinking to be effective and adaptive.
So I knew by the time we get to me all the good stuff.
Take it.
Take it. But, it was interesting when I was asked to be here. I kind of was reflecting back, 20-something years ago when I was involved with designing, deploying large global networks and working with the telecom industry, et cetera. I think what's interesting, and first of all, to consider what's the security threat is to think of the nature and the community, because unlike conventional enterprise IT, where I think a lot of the investment and focus is, the telecom provider is actually really a transport, and so the threat profile, in my mind, is different from kind of the pure play, let's say wireline or wireless, where I'm not necessarily interested in killing the transport because I need that to deploy my attacks and my exploits. So when I think about who's interested in threatening telecom nation states, activists, but as new services are turned up and the nature of the economics of these service providers are, they've got to deploy new services to make money, and they start feeling like those same, they're starting to experience those same challenges is what I think is going to be a problem. And in a way, I think it's a good thing. Because I think it can't happen soon enough to get traditional telecom to start acting and thinking and virtualizing in a way that conventional enterprise and take advantage of all the tools and the services that are out there. Because in that legacy mentality that I think still is out there in the way that systems are designed and presented, is a problem. And I think about the control plane, which has historically been an exposure point. And all the legacy systems that are sitting out there that are gatewayed in to the new packet systems, and that were never conceived to be have exposure, et cetera, et cetera. So I think there's this kind of legacy system and the provenance of the equipment and the securitization of that's going to be a challenge. And I do think IoT is an interesting problem because when you think about where the aggregation point is going to be, for example, the consumer experience of that, who's going to be the set-top box that aggregates that? Who's going to be the entrance point? I mean, I still think there's a lot of easier ways to go about, deploying APTs or et cetera, in these types of situations, which I think is where the opportunity is in the first case. But I think, the last thing I'll mention to be maybe a little controversial with the basic people here is that really this continued debate and discussion about privacy versus what the service provider has to do to ensure trust to its customers, and what the government regulatory and legal environment is going to demand, whether in terms of data retention. Let's fast forward 10 years from now. What if we get in offensive mode? Where does that equipment live? Do I need to be able to operate and inject at the core network? Does that, So there's a bunch of other really long-term implications when you think about that idea.
Okay, so I think it's important, before I answer the question, to maybe distinguish between a physical event and a cyber event, because it takes a different mindset. So we're all used to when there are hurricanes that come through and they disrupt communications. And typically there you may have advance notice, and you also have the luxury of a defined geographic area, right? And so the focus typically becomes on restoral of service. You want to quickly restore service. Now let's think about that in terms of the exact opposite with a cyber event. Typically a cyber event may happen with no notice. It may start out to be a very local event, but the probability that that event could escalate and go regional or national is there. So that's a high likelihood that that could happen. So the focus there is not on restoral of service, but really it's on containment. How do you contain that threat, stop the bleeding, so that it doesn't spread and have cascading effects to other telecom networks or to other particular infrastructures? So, what keeps me up at night? What's the biggest security risk that I think that we face right now that's really going to take some R&D in the future? It's how do we effectively and rapidly neutralize the cyber threats and then stop those particular threats from spreading as a cascading effect.
Well, now because it's going this reverse way, I'm going to add one quick thing. Just to that point, and just in general to the adoption of innovation, I would just point back to the economics and the business models for these providers. Don't lend themselves to A, investing a lot of money in them, B, the availability requirements and the inherent nature of these networks don't lend themselves to upgrades and updates. So I think there's inherent challenges just in it. Even if we knew the solution, we could do that.
Great discussion, guys. Our next question is, our next topic really, is we're going to talk about how the Internet of Things affects the future of R&D. And I want to rephrase this a little bit, because Internet of Things, I think, diminishes a little bit too much to think about your connecting refrigerators and light bulbs. But let's open it up to what I'm hearing called now the industrial Internet of Things, which is basically the move from SCADA, from behind your network inside your enclave, out to SCADA that interconnects with the cloud. One of the problems I see is, everybody right now is focusing on security for the IIoT, the industrial Internet of Things. We're doing very little to protect the old SCADA systems. So one thing that's just, any simple SCADA network scan will show you that, these are old Windows NT systems. They're deployed by folks who traditionally aren't technologists. It could have been the person who worked at the water line or the water plant who said, you know what, I want that next union upgrade to be a GLG 20. And so now I'm the tech person. So you get weak passwords, weak encryption, or you even get vendors who are out there who are doing the deployments. They spent millions of dollars, and now the company is out of business, so it hasn't been upgraded for 10 or 15 years. So while we need to think about how we can protect these cloud deployments of the IoT, which is very important, because with Internet of Things, what's important? Is it the data? Yes, I think that's very important. But what does Internet of Things and SCADA have in common? What they do is they allow a virtual device to affect a physical instance, right? So that could be turning power plants on or off, water pipes on or off, your home lights on or off, right? So how do we protect that by IoT? And then how do we make sure the folks are still in legacy SCADA, which is our largest deployment? How do we make sure that is secure? So some ideas are obviously just you're increasing privilege separation and increasing compartmentalization on your networks. Cisco has a great write-up on a framework for securing the Internet of Things. So with that, I want to hand it down to you guys to talk about.
Well, let's just solve all the problems here in one panel, but...
we can do that, right?
We're really smart.
Yes. There are a lot of issues, right? You have a lot of economic issues where, the vendors for these devices want to make them either reliable or be out there as a significant investment for many, many years, and that's a big selling point. You don't need to update this device, which then conflicts with the requirements of being able to handle encryption or more complicated protocols and error correction and error handling. So you have kind of these two conflicting economic incentives for these companies and these organizations. And then you have the convenience factor and also, quite frankly, the safety factor. If I see something that's happening out in an oil field that could cause an explosion, I'd rather be able to pull out my smartphone and turn it down before something bad happens rather than having to send someone to drive out there. So there are certainly some advantages of this convergence. I think, so we'll put on my Langsec hat as a developer. These protocols that we're using, we haven't really looked at their complexity and some of the unintended consequences of them. So a great example is Zigbee, which is a pretty common wireless protocol that has some pretty significant security vulnerabilities built in at the physical layer, where essentially anyone who can send a data packet can actually get PHY-level access and inject radio frames without having a radio. And so as these protocols are kind of being carelessly deployed, there's a lot of these unintended consequences that create these emergent behaviors. So I think that's the biggest concern in my mind is this emergent behavior that comes out of it. And what to do about it, it's all about reining in complexity, reducing privilege and isolating as much as possible.
So I'll follow up on the Zigbee piece. There was a researcher who gave a talk at DEF CON this past year. And I feel bad because I try and do a really good justice for great researchers and remember their names, but this was in the Wi-Fi hacking village, can't actually remember who it was. And he pointed something out that was really interesting in Zigbee. So if you look in the standard for Zigbee identifies a one-time password, right? And the standards body provided basically a framework for what that one-time password should look like. And they gave an actual example of an implementation. And then this researcher went through and looked at something in the area of like 60 or 80 Zigbee devices and found out that example password was the actual password that was being used, right? So like it's a widely available, publicly open source available password that's being implemented on hundreds of thousands of Zigbee devices. And it's something that you would just brute force, right? Like you would just build it into your script to try it, the same way that you would try a default password or try like 4 zeros or try, like let me in or something else, right? And so to follow up on Jacob's point, there's a language security impact. There's also just a misunderstanding from developers about proper implementation. So I think, one thing that I've been particularly concerned about and I frame this incorrectly on some level with open source projects. I think there were a couple of real big considerations that were brought up in the vulnerability panel about us publishing the source code and making that available to attackers as well as to developers. The real problem, I think, is in ad hoc developed projects, not necessarily open source developed projects, which can have good security controls and checks in place. They also cannot have good security controls and checks in place. But in ad hoc developed projects, you'll have people who will hard code IPs, right? Or you'll have people who will not have run a proper development lifecycle process, or they will have taken that Zigbee standard and they will not have actually read it, and they will have just copy and pasted that password for the one-time password. There's no second round, so that's really nice. And they'll put that into their application. And so we run into this layer 7 consideration around software security. And unfortunately, this is an FCC panel, layer 7 is a really tough one for a regulatory agency to deal with for any number of reasons. I think the real impact for IoT is not necessarily an architectural consideration, but it's that IoT is inherently lended itself to more ad hoc developed projects than industrial or kind of corporately organizationally developed projects. And so there aren't a lot of standards or checks in place, and there's not a lot of best practices that a lot of people will follow. I mean, if you look at the OWASP top 10, those haven't changed in years. Like, the top 10 for this year is still the same top 10 as a couple of years ago. Sometimes they flip rank order, but like it's been pretty static, right? SQL injection, it's cross-site scripting, and the list goes on. And so that part, I think it's really kind of important to understand, to give it a specific implementation, not to SCADA, which has not been my field of research, but public safety. You have PSAPs who are running Windows 98. You have PSAPs who have no physical access control at all. You have PSAPs who will allow people with a name tag that says Steve that he works for an electrical company, just walk in through the front door and take a USB drive and put it right into, any number of devices, right? There is very few frameworks that people actually implement. And I will give a shout out to National Emergency Numbers Association for putting together NGSec, which has been actually effective, but people oftentimes tend not to implement it. And so that's, I think, the real challenge is the implementation challenge, whether that's on software or whether that's on security or whether that's on new architectures and implementations. Thinking through human factors is not something that people do well in security. Whoa.
Just to jump in there, so the standard desktop operating systems architectures have basically been working for the last 5-10 years to basically find ways around all of these software weaknesses from ad hoc development. So you look at the Intel architecture, which added protect-in rings. So originally in DOS, if there was a misbehaving application, it could go and corrupt the entire kernel and take over the whole system. They added protection rings around that. And then you see things like the no execute bit, which prevent a stack overflow. These systems, they haven't been ported over into some of these more modern Internet of Things devices. And so it's basically re-exposing the poor security practices from the development that have been back in the the heyday of the buffer overflow, and that's what we're returning to.
Grab that from you real quick. So Jacob, you were hitting the nail on the head there. We're never going to let Dave.
No, you're good.
By the way, that works out.
It's good hanging out.
Part of the reason we're seeing these previous existing problems popping back up on IoT is that we're on 16 megahertz processors with tiny bits of RAM, so we're skipping. We're not implementing all the security features we have. Now, luckily, there's some folks doing some great research with kernel separation to try to actually build these features back in, but it's not in production yet.
Now you officially took all my ideas. So actually, it's funny because what's old is new again. I mean, M2M is now IoT or whatever you want to call it, what it was before. So this notion of securing, machine to machine or unattended device communications have been around some time, but not really worried about a lot because the same reasons, this concept of air gapping and who's going to attack the internet, et cetera. But now it's becoming a more pervasive problem. And I've actually had the privilege of even building a SCADA product and learned a lot more about pump stations than I ever thought I would and what happens when they don't work. But I think to the point I think we just talked about earlier is, there's both a problem and opportunity. And there's this trade-off between compute horsepower and economics of deploying these devices, which are often in insecure physical locations and remote locations that have access by third-party field service providers that could do all kinds of interesting things if that was somehow a backdoor into environments. When I think about the industrial environment versus maybe the grid where you can go in band, if you will, modulating on the line, et cetera. So there's varying degrees of exposure to physical access that I think is a real threat. I think this other challenge is that, in the arms race of threat vectors, I still think you're going to really be challenged to see IoT have the horsepower to fully, react to threats. So there has to be some level of automation and system-level aggregation that have to cooperatively work across a vast array of nodes to really synchronize protection. And I think that's a tricky problem at scale. And I don't mean, just your local plant, but at much bigger scale. So I think there's a lot of interesting work that can be borrowed from work that's being done today on virtual nodes and the traditional environment that can be brought into those areas. And by the way, I just also maybe just touch on the traditional telecom environment, back to the earlier point about everything's getting faster and more data. Well, one of the challenges in the wireless space is, hey, I have this fixed infrastructure that costs a lot to add to. So I've got a backhaul that I don't want to overflow with all this incoming data. So they're pushing more and more to the edge, right? More and more of the capability is pushed to the edge. And in a way, I think there's a lot of interesting lessons going to be drawn from solving that problem, where you've got more exposure to critical infrastructure at the edge, where it has more vulnerability, in my opinion.
So I wanted to comment just for a minute or two on how big a deal this IoT really is. And so I was looking at some recent stats. 7 billion people in the world today. We have about 25 billion internet-connected devices. I think by 2020 it's projected to double, so 50 billion. devices, incredible amount of devices that are going to be out there. And it really is the intersection between cybersecurity and the physical world. And so you'll see a lot of the IoTs, I think, initially start out trying to meet some of the security best practices right from the start with development for those that can. Where I'm concerned is the real hard problem. And the real hard problem is to address the end of life with IoTs. So the devices that are out there that are going to outlive the security that's been programmed into them, you don't want them to become your next Windows XP, right? So that needs to be thought about. That's a real hard thing to do right now, especially with the low cost, high volume, first to market. Everyone's going to win with this. But it's something that definitely needs to be thought about. No silver bullet there, no answers. But anyway, something for us to keep in the back of our minds into life.
Good discussion, guys. One thing that we have with IoT was we just said about building best practices in. Unfortunately, I'm not seeing that in any literature. Like, for instance, if you were to download one of the most popular IoT build platforms now, which is the Intel Galileo or Edison, right? They're really going hard into it. None of the software packages for the operating systems have passwords. If you look at their hardening guide, they don't exist. So I think people are kind of forgetting. Oh, well, it's a little thing; it doesn't matter. So hopefully, by building this culture of security, we can help that change. Our next question was, what sorts of innovations are needed in the field of cybersecurity to make meaningful improvements to the state of security for telecoms? So what I think about that is, what can we do at scale? Telecom, the providers, it's a different challenge than how we normally think about security, which is the enterprise, endpoints. So on the backbone, how do we make meaningful improvements there? What sort of research do we need to focus on? One area that I think is obviously important, being an instructor here, is that we need to get the right folks out there in the field for you. So we need to make sure we're teaching the right things beyond teaching your traditional penetration testing and analytics. How do we teach that at scale? How do we go further than just teaching? And how do we give you the tools you need? What type of analytics are available? What type of analytics can meet the scale of the telecom backbone? We talked earlier, you can buy security. We've all been in that meeting with a company where they just spent $15 million after being hacked to buy every SIM they could, every firewall they could, and then they still haven't increased their staff, so they've got 6 people for 3 million alerts a day. So how do we change that? I think a big part would be research into building security in from your vendors, for your deployment, and then for your SOCs, and then how we need to build this new type of monitoring that can go at 160 gigs and beyond that. So with that, I'll hand it down.
I see this as kind of those two main categories. One is, how do you protect the legacy that is always going to be there? And me in the more research thing, I always like just to assume there's no legacy, which is a very wonderful little world I can live in, but unfortunately not the real one. So we have the legacy support, and how do we plumb that in without leaving that to be the next Windows XP, for example? And then we have looking forward, how do we build in security? A lot of that comes from the fact that we just really haven't got that down until very recently on modern, kind of standard COTS systems. And so I think that that's really where we're struggling. And some of this comes from an education gap. I'm not sure how many of you guys are computer science. I didn't take a single computer secure programming course in my undergrad or my master's degree. So with that, I'm sent out and told to make software that's going to run in the federal space with no background on what's secure programming, how do you write a secure parser, how do you handle untrusted inputs. And that's what you have to realize, is that your inputs that you're handling are always going to have to be untrusted. So I think that's, looking at those two things, something that spans across it is metrics. You can hire a pen test team and they will tell you one thing. They will say, yes, there's a way that we can go in for this amount of money and write a report saying that you can get hacked that way. But does that increase actionably your security performance? And that comes down to, I believe it's either Dan Geer or Bruce Schreiner have this kind of debate about, are bugs sparse or common? If they're common, then you hiring a pen test saying, yeah, we found a way in, very likely is not going to be the same way another attacker will make it in which case it doesn't matter. So figuring out how you can actually measure your security in a objective way, in a way that you can measure and kind of track over time, I think is going to be the most important thing, because if you can't track it, you can't measure it, you really can't see if you're improving or not. A lot of people in this community, as it's a new field, they say, well, we're doing something, so hopefully that's the right thing. And that's unfortunately not where we want to be.
So the efficacy of risk-informed thinking doesn't lend itself particularly well to telcos, in part because, traditionally their job has not been to secure everyone's connections, right? It's been to protect their internal enterprise networks, not your network, right? So just from a strategic perspective, they're not necessarily in that business. Senior executive vice presidents at X, Y, and Z telco have said if you want to, be secure, you can buy security as an application. We don't necessarily provide it. One of the challenges for them, I think, is there are market considerations. So Moody's credit rating services came out, I think it was 2 weeks ago, and said that they will incorporate cybersecurity risk when making a credit decision. That's huge, right? Because the lifeblood of a company is credit. And if you can effectively influence that, then you can start moving the needle. There's just not much of a downside, though. Greg Foss, brought it up earlier today. If you look at the stock market ratings for Target, right, their share price is up after the hack. It was a massive, awful hack in which hundreds of thousands of Americans, millions of Americans, credit card information was breached, and they're making more money than they were before. Of course, to be honest, the worst thing that happened there, this is the sad part about it, is people had to get new credit cards, right? So that's different from a CIKR sector, where there is real downside to critical infrastructure if it gets hacked, right? These are very different things. But I think part of it comes down to there's a lack of trained and educated individuals who have operational and technical abilities, right? There's a lot of people who are great at research. We need more people who are better at working on network security and AppSec pen testing and threat intelligence analysis, and not necessarily just long-form research. Those are two important things, but they both have to be done, and they're not mutually exclusive. Part of the other part, though, is once you have a staff, they have to be able to do something predictive in order to be effective. And so further research in the areas of predictive intelligence analysis married with network and system operations are an effective way to start mitigating threats over time, as opposed to historical research on vulnerabilities that have questionable outcome with adaptive actors. And then I'd also say there's a real question about whether or not telecoms are in the job of availability, and if that's mutually exclusive with confidentiality. And so this has been brought up by the FBI director and the CIA director around end-to-end encryption, about what the proper role for telecoms are in the securing of information and the enablement of privacy and confidentiality. But I don't see them as necessarily mutually exclusive, but telcos aren't doing a lot of work in protecting the confidentiality of their customers' data so much as they are of the integrity and confidentiality and availability of their internal networks. So it's a question about roles and responsibilities.
Yeah, absolutely. I agree with that last part, and I think it's going to continue to be more and more important challenge as I think, nobody has a crystal ball, but I suspect there'll be continued pressure to thread that needle between privacy and then with the additive services, where essentially the data that is being stored and captured is going to become even more valuable to an attacker or to exploit as well. But the other interesting thing from my perspective is that, and maybe it's a little contrarian, but I actually like that the networks are speeding up, because I think it actually makes it harder to exploit. At least we can walk up and down the stack, right, for a telecom or service provider, but I actually think it's good. And one of the technology areas where I think that can continue to accelerate that is in optical networking. and pure optics networking and pure optics switching, because it really makes it a larger challenge, one, to get into that system, because you're working at speeds that, I mean, think about it. If we're at the core, I mean, what's the reality that I'm going to be able to steal a lambda and add drop, demux, go all the way down the packet level, to your point, do something, exploit, and then run it back and put it all back together. Oh, by the way, with the compute horsepower that happens to be laying around and accessible on the premise. I mean, that's a pretty unlikely thing. And so if we could get to low cost, pure optic switching all the way through, you can begin to do some interesting things by aggregating data at the optical layer and really just pipelining, which is what's really done inside data centers today. It's just kind of a way of doing traffic management. But if you could do that more broadly and have the economics of the equipment be cheap enough to be deployed further outside of the core, I think there's some interesting opportunities from self-protection on that point as well.
So let me just add a couple additional thoughts. I certainly agree with a lot of the statements that have been made in terms of the innovations and improvements that are needed. But let me add to that two additional things. The ability to forecast threats based on big data analytics, I think is going to be incredibly important as we move forward and require some innovations, but also situational awareness that leads to actionable results. And there, let me pause and say that from a perspective of situational awareness, it's very, very important. I think the point was made this morning that you need to be able to communicate to the audience, to the people that are impacted, to the farmers, I think was brought up. So they need to understand in terms of situational awareness what the impact is if they have some cyber threats to their equipment and them being able to harvest their crops. That's the sort of thing. Talk to the financial folks in terms of their currency. No pun intended, but whatever you need to communicate in terms of situational awareness to the audience, I think is something that we as practitioners really probably need to do a better job of, so that we step away from a lot of the acronyms that we use and we try to explain the things in terms of simple terms that they can understand, the impact and what it really means when they get actionable information. What should they do with that? So those are a couple thoughts that I had in addition.
I have one last one for public safety. So in the context of 911, I mean, one real concern that I've had, I mean, it's questionable whether it exists the same way it does in, for example, Android smartphones, but whether or not the ability to deal effectively and quickly with rich media as methodology for providing an exploit. So in Android, stage fright is obviously something incredibly concerning in the code base that allows, an attacker, to encrypt binary onto a multimedia, an MMS, and then exploit the vulnerability in Hangouts, which automatically opens up the message, right, and then it executes binary. The challenge for 911 is that that's a well-advertised number that everyone knows, and the ability to effectively quarantine rich media, interdict rich media, interrogate that rich media, and then be able to still make it available to a 911 operator quickly and effectively while mitigating any vulnerability of encrypted binary in the image itself or in the video stream, that's a really hard thing. And no one has done, I think, almost any work in that area. And it's a really big problem that we find in other areas of the general telecom sector. But it's not something that telecoms are used to deal with, right? Because it's a software vulnerability as opposed to a denial of service attack or an exploitation like Reagan or other attacks that target telecom tier 1 backbones. These are very different and non-analogous things, and the attack surface is very different, which is why thinking through the threat actor is the important part of the equation that's often missed.
Guys, the time left, I'm actually going to skip one of the questions and just jump to the last one. So what is the pace for academia and research in the development of product meeting these strategic goals? So what can we do to speed up the research in these areas? do we need to fund more national labs? Do we need more small pockets like here at CU? Do we have problems that we can fix for you that maybe doesn't fit into a traditional national lab area? I think there's tons of room for improvement, tons of room for investment in training, investment in these high-speed analytics. Vern, as you said, with situational awareness, that is one of the key things to security, being able to know what's normal and know what abnormal is. Can we do research there? Alex, like you said, with the changing of how we're thinking about telecom with the multimedia tech versus traditional just monitoring the backbone. Do we need to think of, there's been sandboxes for forever,
Yeah.
but do sandboxes scale to the 911 level, right? Do we need to think about how we can adjust that? Personally, I would love to see more, obviously I'm biased being here at the university and at another national lab, but I would love to see more investment in some of the approachable problems, right? There are the deep dives that we need to do, which is the near real-time analytics of malware through E911. So we can have projects on that. We could have projects on how do we help telcos and ISPs provide a friendly router that's also secure and can let you make out of the box a segmented network for Internet of Things, a segmented network for your mobile phones. Now that mobile is a new rich platform for attack. So these are areas I think that that academia could definitely help out. So with that, I'll pass it down.
So I think there needs to be more communication between industry and education. I think academia has solved a lot of problems, but they've ignored maybe the legacy issue, or they've ignored the scale that is needed and to really focus on for these upcoming data links. And so I think there needs to be more of embedding university students in real world so they can understand what it's like to have an investment of millions of dollars in legacy equipment that you can't just assume away like you see in many abstracts of academic papers. We assume PKI is a solved problem, and now we move on to solve a very small problem. So that's definitely one thing.
It's not. Is that not? Do we not do that?
Well, we're secure for everything up till today. It's tomorrow we don't know.
Yeah. But we did PKI.
As for the pace, I think that from a regulatory perspective, understanding that as a researcher, we're researching technology, trying to solve problems, and that technology can be spun to either offense or defensive purposes. And so when you try to regulate offensive research, such as the Wassenaar agreements and putting restrictions on exploitation development, which is basically just a proof of concept to be able to prove out a theory of how a program works, you are then putting a bar on defense as well, because it's the same technology that you're going to use. So putting regulations on this area, especially when we're so far behind and we're kind of losing in a lot of cases, I don't think is a very helpful way. And so I think reducing the borders to boundaries to enter, and also reducing the red tape and paperwork when something is moving so quickly, especially when our adversaries have moved from a traditional nation state to any pissed off kid in their mom's basement. They don't have the red tape of having to go through and get export control permissions before they can collaborate with a researcher.
Here.
They just go and do it.
Yeah, I'll echo that. I mean, besides just Wassenaar, like DMCA is a ridiculous impediment to doing good security research, and policymakers should rethink that, or less attackers will just completely take advantage and pwn the legal and regulatory system to harm Americans. But that aside, I'm much less. Look, I'm not a particularly good academic, right? So, from a researcher perspective, there are long-form areas of research that are of incredible importance and interest, right? From compute environments to optical networking. I think my concern, though, is that, at a lot of research universities, CU Boulder being a really great exception, a lot of it is, white papers that end up sitting on a shelf, or intellectual property that's been developed that doesn't get commercialized. So my area of focus has been in collaboration with startups. So we run what's called the Startup Accelerator. The Startup Accelerator is a program by which we compress the development life cycle and provide funding for startups. And so we do this specifically in cybersecurity. We don't do it in anything else. We only focus on cybersecurity. And our purpose here is to try and identify incredibly thoughtful startups that solve actual problems that corporations or just organizations more normatively face, right? And we do this by understanding the technical requirements of both the potential customer, but then also the technical requirements of the industry sector. For example, like what endpoint security solutions do healthcare companies care about? Or what are the things that telecoms are really interested with threat intelligence analysis? And the commercialization and the funding of that, I think, is a really important part of the equation. But it has to be done in collaboration and consort with academia, because new ideas actually have to have the intellectual rigor of an academic environment, because otherwise we have no idea whether or not they are proofed out to actually meet the requirements of the industry, or whether they'll be just another device that looks exactly like this other device. I mean, you walk the RSA floor or any of the large trade shows, and there's hundreds of new cybersecurity startups, right? But how are they any different from each other? I have no idea how your firewall is different from my firewall is different from this guy's firewall. And if they're all based on the same underlying assumptions for engineering logic, then aren't they mostly vulnerable to the same implementation flaws? And those are really, I think, important things. So I'm actually much more interested, though, in the area for investment capital, because that's how we actually start productizing some of these things. Whether there's really simple solutions for working on human factors considerations, or whether they are a methodology for improved compute environments just for security. Those are important concepts, but they need to exist outside of just research papers, and they actually have to become companies with products that people can buy and can implement and can be held accountable.
Yeah, what he said. So I'll just kind of I'll echo a lot of things. I've probably spent the last 15 or 16 years collaborating with the university environment, with the Department of Defense, all in this idea of commercialization and the classic battle between the R versus D, applied versus basic, et cetera, et cetera. And I most recently was an investor in residence for Texas Tech University, helping them with this problem. And I think Alex is right. I mean, you've got this tension between the incentives and the mechanisms of academic staff and how they're rewarded and how they think about allocating their research and what they focus on versus maybe what the industry is calling for, both short and further term. And so I think the opportunity is less about, wow, do we have enough capital going in to basic research or kind of fundamental research. It's really how effective is it being used and then in turn commercialized. And there's always that missing gap in the commercialization because there's such a stark contrast between the experience base of much of academic backgrounds and that magic world where you turn an idea into a product because people buy technology, they buy products. And so I think that's the opportunity for a university. And again, all the great things that Alex said. The other aspect that you might also think about is additional collaboration with other agencies and service outside of academia. And that already happens to an extent, but I think security in particular, there's an opportunity for more collaboration across that group.
And I just want to add on to that. I really want to stress the importance of the interdisciplinary approach to the cybersecurity. If you think about it, there's a lot that you could learn from some of the other verticals, some of the other sectors, such as transportation, for example. So if you think of an airliner flying, they do a great job of segmentation. So if something happens to fail in flight, right, something will trip, a circuit breaker will trip, and they'll try to isolate that as quickly as possible. The alarm will go off. The plane should keep flying, right? We need to take that same approach in terms of how we're looking at the whole discipline of cybersecurity, and have others that have looked at problems in different ways through these other verticals and look at cybersecurity from that particular lens. I think we'll learn a lot. And so, much to the credit to CEO here, looking at the interdisciplinary approach that you've taken to cybersecurity, I think is really going to pay off.
Okay. So we have time for one question.
Oh, God.
Thanks. Trey Fogarty with the 911 Association. So if I were the sort of person who was in the business of haranguing government agencies to say, here's what you should focus on.
That's my business.
I've heard the... I've heard this panel talk about sort of what I'm going to very, very generally classify into two different sorts of cybersecurity problems. One is the Kevin Mitnick kind of problem, where we need to deal with user failures occasioned by social engineering and the like. And the other is the sort of Zach Franken problem, where we have people reverse engineering embedded gadgetry, and we have lots more embedded gadgetry now. What should I be saying? You know, shoot a shotgun, go after everything and all of this? Or should I be saying come with a rifle and pick one or two things here and there that are going to be really productive? Is that something that we can know now? And if the answer is no, what do we need to do to find out the answer?
Well, that's a good question. And what I think you need to do is treat it as any other security problem, right? Which is there's not one thing you can do to make it more secure, but there is the layers, right? You have to protect everything in a layered approach. But from your enterprise or for your deployment, you need to look at what are your areas of risk, right? What can you accept downtime in? You know, what are your main targets? Where do you need to protect? Now, something like 911, if it's going to be phone calls and social engineering, obviously it needs to be a big part of it. If it's a web application where people can now go on and submit crisis calls, then you need to protect all the inputs there. So it really depends on how you do it. So you'd have to, I would think a great thing there would be to pick up a assessment methodology and pick up your highest risk targets. So something like, once again, I'm a fan of Octave, so looking at that, or maybe the resiliency management model, RMM, might help out with that to try to figure out where you need to focus.
I think Dan Geer captured it very well in his Black Hat keynote. Dan Geer is the CTO of Intel. Basically, software liability, if you're going to go and pester your government regulators, you know, if I'm using software as I should and I get compromised, you know, there should be some form of liability to the company that put that device in my, or turn that feature on regardless of whether I want it or not. And so I think that if you're going to pester them, you know, looking at figuring out what kinds of economic or market incentives you can apply to companies to improve security. Right now we have, as Haroon says, at least in the security market, considered a market of lemons in security space. Mm-hmm. The people who are making purchasing decisions are not given the actionable and detailed information about the products they are buying. There's very little incentive for a security company, say like FireEye or whatnot, to really invest in making those products secure, because there's really no way other than a huge in-depth pen test or reverse engineering exercise to be able to understand what that device does and how good it is, because at that point there's very little incentive to invest in engineering over marketing.
The Kevin Mitnick problem is always going to be the problem, because like you can't fix stupid, right? Like, especially like there's no regulator who can fix stupid, and so like I mean I've been phished and like I'm only sometimes stupid. So I mean it's a numbers game. Those aren't things that you can effectively protect against with any kind of government regulation, right? So that brings us to the other side of the equation, which are what are those technical things that we can do? Well, I mean, I would be very happy if I woke up one morning and I found out that there was a government incentive program for bug bounties for companies like, you know, embedded systems companies to offer bug bounties to security researchers. That would be great, because the number of like medical health devices that are coming online are through the roof, yet almost none of them have any kind of bug bounty program. There's no incentives for anybody to do any actual security research. You can't get paid for it, and you'll get slapped with a DMCA violation if you do it. So it's a problem that government and policy can solve. I think a lot of people focus on risk management. I'm kind of down on it because I don't think people do it particularly well in cybersecurity. But I think that's the other side of the coin, which I think Joe got to really well, of trying to figure out specifically like what are your high risk targets. I mean, you know, the big thing that's of interest to people in, you know, the DC echo chamber, you know, which I was part of for a very long time, is threat intelligence sharing, like information sharing, which is valuable if it's done effectively. It's mostly not done effectively. There's not a lot of incentives to do it effectively. So, I mean, there have been incentives reports written by the Department of Homeland Security, by the Department of Treasury. There have been working groups at the Department of Transportation. There have been frameworks developed by NIST. There's been work done by DISA. And all that's fine, except they never actually rolled the implementation. And so like there are like 20 some odd incentives that have been identified by Homeland Security, and they can't get Congress to move the needle, which is hard. That's a political problem. But if you're looking for, what's the role of, government in a lot of these areas, I think it's just to allow security researchers to do security research and then incent them to do more of it and make it more effective so it's potentially scalable, and then reward people for doing good work. If there was a government agency that would do that, I would applaud that.
No, I really don't have anything.
Yeah.
Maybe just a comment from an independent government agency here. I think we need to go back and look at what we're trying to do here. So we're trying to minimize the cybersecurity risk, right? And so folks know that risk is really a function of the assets that you have with vulnerabilities and for which there are threats. So my response would be, let's be laser focused on making an improvement, at least in one of those areas.
Yeah.
What I would say is let's be laser focused on threats, okay? Because you're always going to have assets. You're probably going to have vulnerabilities. There's lots of folks out there that are looking at the vulnerabilities. But that's probably, they're going to be out there, right? So let's be laser focused on threats. And then let's make sure that we share observable information across sectors when we see various cybersecurity threats. And so we share that across sectors. We use the concept either through this information sharing and analysis centers, or the new concept that goes across sectors, the information sharing and analysis organizations. But we basically provide that information when you observe something. You provide that information out, and that information that you provide out then can be acted upon by the other sectors based upon how they view their particular risk. So my answer, Trey, would be let's be laser focused on some threats.
I have just one last thing, because it was something that an individual who does security research at Apple said that I found particularly profound, which is that security researchers are like the 21st century consumer advocates. And I actually really love that idea, that people are, that a lot of security researchers do this for particularly good reasons. Now, there are bad reasons, too, why people do security research, right? It's effective to monetize. And so there's like an inverse yet corollary relationship between, the vulnerabilities of a system and the price that people are willing to pay for exploitation. And that would be something that I think would be great, to go back to your last question on what academia could do more of, would be to help define out like what the economic framework that incents people to do awful things is, and how do we get in front of some of that. So, sorry.
I'd like to go back to the comment that was made about threats, and at the risk of disagreeing just a little bit with my own teammate, I'm concerned and would be interested in the perceptions of the panel with regard to the laser focus around threat. Mm-hmm. Because in all my experience in information sharing in cyber, it sounds great, but the amount of threat information that I've gotten that has allowed me to be predictive about the next attack, I could probably count that on one hand. And the reality is, I think that that's not helpful to most enterprises if it's not accompanied with a remediation or a mitigation to that threat. So if I were to laser focus on one aspect of information sharing, it would be more around the sharing of actual mitigation information in a machine-to-machine way once it's made available, so that I can actually do something with it, instead of making everybody smarter about a threat for which most enterprises really won't be able to make an actionable decision about that threat.
Oh, wow, that's a good question. Well, we have MITRE with the CVE and US CERT with their knowledge base that's really helping out with that. But I think the only way to effectively put it is, you said, if you get 100 new alerts a day, how can you handle that, right? So what I've seen enterprises do effectively is to make owners of systems. So if you're the one who has to pay attention to the web server threats, or you're the one who has to pay attention to the enterprise authentication threats, That's the only way that you can actually do anything with it, because there's too much information out there coming out, which I don't think is, I'd rather have too much information than not enough. But you need to have people who can actually ingest that data. So it comes something we've harped on a lot today, which is getting the right people in your SOC, in your NOC, that you can look at this data and make decisions based on what's coming through. So
I'm actually going to disagree with you. I don't think you want to have people who are receiving millions of responses, and those are going to be your bottleneck. As you said, so there's deny hosts or fail to ban. It's essentially what you're asking for. It's an open source tool that when you receive so many invalid logins on your system, it'll automatically share that information with everyone else, and for the next 5 hours, every system with this open source tool on it will block that connection. Now, that's not enabled by default, because it's very easy for an attacker to go in and say, you have it's Black Friday, and you have a lot of people coming in from Comcast. You can just grab on a Comcast system and then basically DOS Amazon.com. So there has to be something more where you have a trust element. And so I have these regular dinners with CISOs in Colorado, and they all trust each other, and they communicate this, and they would actually trust allowing someone to say, I did the analysis on this flag on my SIM. I'm going to say, yes, this is bad, and then they can push it out to all of the other CISOs. But also another thing against this is that organizations need to understand who is out to get them. And I think that's a fundamental failing for most people. The federal government has a much different class of an attacker than someone running a home website. And so folks at the kind of the smaller end of things, they're going to have typically financially motivated attackers who are going to try to use automated things, and basically it's an economics issue. If I can make it more expensive to attack me than to attack him, they're going to go for him, and that's fantastic. The federal government obviously is a slightly different.
No, it's not.
Slightly different creature in the sense that you have political or kind of outside of economic reasons for that, and then also you have corporate espionage in some verticals as well. So until you can understand the specifics of who's out there, it's very difficult to be able to ingest that data in a meaningful way without opening yourself up to shutting down potentially legitimate customers. So if you're a multinational that does a lot of work with, say, Russia, you don't want to block all Russian IP addresses, where if I'm a local sports still and I just sell footballs or whatnot down the road to local people, I'm not going to have very many people coming from Russia to visit my website, and so I'm not going to lose any traffic by blocking that.
I will say one thing, which is the marketing that's being done around advanced persistent threats is not helpful. It's not helpful at all. It's incredibly counterproductive. This idea that you've just got APT everywhere and everyone's out to get you is completely is the opposite of helpful. The only people it helps is people in marketing and sales. And so the reason why I'm so hard to focus on threats is because I think that by doing that, you'll actually start to provide a level of intelligent analysis as opposed to fear-mongering, right? The PLA is not out to get my company. I know that. I have no information of any level of importance or interest. Yet I had a sales call from somebody who works at a vendor who told me that they identified that I am open to APT. And to which I asked him to go on, and I just put the phone down for half an hour and I did other work because I want to waste as much of that guy's time as I possibly can. But the reality is that, you're right, we want to focus on mitigations, but we want to focus on mitigations to the high priority threats, because the idea of focusing on script kiddies is not going to be helpful if you, quite frankly, are vulnerable to so many more impactful things. I think that part's really important, and we have to clean up marketing language and empower people as opposed to strike them with fear.
Yeah, that's the thing is there's a lot of money in marketing the next big thing and the shiny boxes with blinking lights.
Yeah.
But if you look at the categorization of how breaches occurred, number one is social engineering, so a phishing attack. Number two is just poor passwords. I gave a lecture actually earlier this week at his startup about just password security and how sometimes government password policies where they basically incentivize you to write it down and then create a culture where you're always calling and resetting that password.
Yep.
So your help desk is kind of oh, Bob forgot his password again, no problem. And then if you're a Kevin Mitnick type person, it's very, very easy in that organization. You've created a culture of understanding. Whereas maybe you allow much longer passwords that are a sentence, like the XKCD's correct horse battery staple, which is much easier to remember, much harder to guess. So that right there, I think 22% of all breaches are attributed to poor password security, which is a much larger than that small APT. Honestly, I feel like if my organization got compromised and I was able to attribute it to someone with a custom 0-day that they paid $150,000 for, I'm going to pat myself on the back because it means that they tried phishing, they tried social engineering, they tried guessing my passwords, and everyone in my organization was able to basically rough that and be able to defend it. If they had to go and find an 0-day in Apache or some firewall, that's great for me. So.
Yep.
All right, well, I might just add one quick thing. This is an observation, kind of looking at this from an investor-centric view and validating market needs, really through the lens of incident response platforms that are looking to enable that kind of information sharing. And actually, when I first looked at the state of incident response, I was shocked to see there really wasn't a kind of a software as a service version of incident response. And there's a lot of the normal suspects in that space that talk. But I think there is an opportunity to kind of, particularly around verticals and industries, for trusted information sharing. I think we've just heard, and forums around that I think can be successful. The other thing to think about, though, and the problem we always had from an investment perspective in scaling that type of solution from a business model perspective is who's going to pay for it. Once you get out of the Fortune 100, Fortune 500, who's staffed with somebody to even human ingest that? And so, which begs the whole security as a service. And as everybody marches to cloud outsource, maybe that'll kind of happen. But there's a huge opportunity. Yet well, if we could do that, right, we've solved a lot of other problems. I mean, it's the end of the day.
So I know you had a question, but I believe we're out of time, aren't we? Okay. So thank
Sorry,
you all for listening to us this late in the day, and we'll have our wrap up right now. Thank you. Good job, guys.